Views and news with Clarence Ford.
Share your perspective.
Only on Cape Talk.
It's 9:35. This is Views and News. My name's Clarence, and it is time for the Naked Scientist. It is time for you to tell us or to send through your question that you badly want answered. Dr. Chris Smith is the consultant virologist at Addenbrooke's Hospital in Cambridge, and he joins us every Friday. And yeah, it's an opportunity to get that question answered. Welcome, Chris. It's always great to have you, and I believe you are experiencing some great weather in Europe. Or is it too much for you?
Hello from the sauna. Yeah, it's really hot. It's going to get hotter again today. Sort of ridiculously hot, sort of mid-30s type temperatures that are just unknown. And yes, it's nice to have some nice weather, but not this extreme. And we're just not set up for it. I mean, obviously, in some parts of the world, 45 degrees is perfectly reasonable. And, I've driven across the top of Australia, across the Kimberley, across the desert, and it was 45 degrees in the shade every day. But you're set out for it, you're equipped for it, and you expect it. In countries like the UK, where you expect it to be cloudy and rainy, it's just not what people are used to. And it has brought the country to a bit of a standstill, to be honest. We've got schools are closed, people are not travelling easily on trains because, A, the trains are really hot, but they're just not running, and certain businesses have shut down, and also certain websites, not in this country, but people who are hosting websites in other European countries are seeing their websites go down because data centres are getting too hot. There was I saw one particular company advising its subscribers, don't try and log onto our website today because our data centre's overheated in France and it's all gone down. Wow. So, yeah, I think we need to plan a bit better because all the predictions suggest this is going to become a lot more common as the world warms up.
And this is ahead of a super El Nino. So the immediate future looks even worse for Europe when it comes to heat.
Well, remember that El Nino is this patch of warm water that moves backwards and forwards in the Pacific Ocean, and it therefore has a very powerful influence on weather patterns and climate down in the southern hemisphere, particularly America, Australia, etc., either side of the Pacific Ocean. Nevertheless, there are some knock-on effects for the northern hemisphere, but they're going to be quite diluted. It's not the heavy driver that you get down in the southern hemisphere for us, El Nino, but it's all connected. And the fact is that as the world warms, because there are a range of reasons why the world warms, there are natural cycles, but there are also forcing effects of us putting lots of carbon into the atmosphere. Those effects are undoubtedly going to, the models suggest, increase global temperatures. That puts more energy in the atmosphere, and that means bigger storms, more frequent storms, but also bigger departures from what we regard as normal. This is a big departure from what we regard as normal. What's actually happened over Europe is that the jet stream, which is this thin band of air that circulates about 5 to 8 miles above the planet's surface around the north of the planet. And the reason it circulates there is because you have warm air coming from the tropics below, cold air coming from the Arctic above, and it segregates this band of high-moving, fast-moving, west to east flowing air. This normally sort of ripples along at a certain latitude down from the poles, but occasionally it deforms and distorts. It's a bit like you're getting a loop in a piece of string, and a loop has formed looking a bit like an omega symbol with the omega circle centered on Europe and some lower pressure either side of the jet stream, and this is pinching a big blob of hot high pressure over Europe and creating what they call a heat dome. So the high pressure sits there, stopping any other air systems moving in and concentrating air in that patch, which then has lots of still air, lots of clear air, and therefore lots of sunshine heating the land. And it then becomes a self-fulfilling prophecy because it's very stable. It just gets hotter and hotter, which is what's happened. Parts of France are seeing sort of 45 degrees at the moment.
Yeah, and some sad stories reaching us from France this past week as well. Let's get on to a question from Max. Max wants to know if a 4D being walked into his 3D office, what he would actually see.
I'm not quite clear on the question. Say that again.
A 4D being, so we're talking an interdimensional being walking into my 3D office.
Right.
What would I actually see?
Well, remember the fourth dimension is actually time. So we see an X, a Y, and a Z coordinate, and then the fourth dimension is the time. So I would hope that an alien would experience time at the same rate that we do when we're here on Earth. We're in the same gravitational field and hopefully the same other coordinates. So the fourth dimension being time. But if we imagine other dimensions, I think that's probably what he's getting at, that are not quite so familiar to us. Well, it would depend, because it's perfectly possible to exist in one of these other dimensions and we would not know we're there. We could totally pass through one another in the other dimensions and we wouldn't interact. What do I mean by that? Well, an easy way to think about dimensions is if we imagine a straight road, that's one dimension. Now imagine a crossroads, that's two dimensions, X and Y. So a car on the straight road, if there's two cars on the straight road, they could be on top of each other. If there's two cars at the crossroads, they've got different dimensions, but they could still meet at the crossroads. But it's possible if I build a flyover or a tunnel under the crossroads, I could have a car and another car in the same X and Y dimension, but if one's on the flyover or in the tunnel, it won't see the other car sitting on the crossroads, so there wouldn't be an accident. And so that's how you can sort of begin to think about these additional dimensions. So there may be a car there, but you wouldn't see it because it's above you or below you. It's out of your ability to see that dimension. So it would really depend on whether we had any kind of way of detecting that dimension to know whether the alien was there. And people also invoke this sort of thinking when they're saying if there are parallel universes, because we don't know the universe we're in is the only universe, if there are multiple universes, and there's some aspects of physics that posit that this may be a possibility, then it's perfectly possible you've got all these other universes and they are drifting around next to each other and we don't know they're there because they're in a different dimension. One thing that the theory does predict, though, is that gravity probably would convey from one to the other. And if we could detect gravitational waves coming from those other galaxies, then we'd know they were there. We could probe them. And that's what an experiment called LISA, which is a laser interferometry space telescope that they're currently constructing and is due to fly in the years ahead. It will be millions of kilometres long, this telescope. Effectively, it's a telescope, but it's effectively a detecting system. This would detect gravitational waves from things like other universes. So the notional alien would be detectable via its gravitational effect, potentially, that way.
And the hair at the back of your neck is not alien detector at all.
Hopefully not.
Okay. I'm reading the question verbatim. Don't shoot the messenger. How does a wombat able to produce how is a wombat able to produce cube-shaped scats? They are the only animal to do so. That from Vernon.
Yeah, I've seen this, and I don't actually know the answer. So I'm going to have a bit of scatological homework. And I've certainly talked about the story before, because when it was documented, we talked about it many years ago. It's about 15 years ago, I think it came up on The Naked Scientist. But I'm not sure anatomically how they do that. I strongly suspect it's going to be to do with the way that the intestine moves things around, the composition of the poo, the consistency of the poo, because the shape that you get is going to be down to how things are moved through the intestine, how they are, or what texture they have, what's in them, and then how they're deposited. And so that will have a strong effect. But I'm going to check this out properly and come back in a couple of weeks' time, because I'm going to be away for a couple of weeks. I'll come back with a well-researched answer.
Your questions for The Naked Scientist via WhatsApp at 072-567-1567. And you can call at any time at 021-446-0567. We'll prioritize your call. Now, the question about heat in Europe, it's a WhatsApp from Jason.
Hi, good morning, Clarence and Dr. Smith. Quick one, you talk about getting so hot in Europe at the moment. I stayed in the UK for 8 years, and then I eventually got to a stage where, it sounds funny, I could wear shorts at 10 degrees and a t-shirt at 15 degrees. And I'm from Cape Town. So the question is, do we adapt to the environment in terms of getting used to cold weather or hot weather? And if that is the case, how is that so? Anyway, thanks for a great show. Jason here from Brackenfell.
Thank you, Jason. The answer is yes. Humans are extremely adaptable. And if you think about all of the different climes that we have conquered as a species over the, I suppose you could say 500,000 years since we emerged thereabouts as anatomically modern humans, or things approximating such, we've managed to live in the far frozen north. We've managed to live in the extremes of the deserts. And so we are extremely good at handling temperature. In fact, as some scientists have postulated, humans are amongst the best animals at regulating their body temperature on Earth, to the extent that if you think about the Kalahari Bushmen, they would catch their lunch by running after it because they were better at handling high temperatures than the animal they were pursuing, which would eventually collapse with heat exhaustion, and they could pounce on it. So we do adapt. We can train our heat control systems. You can control how much you sweat, and if you ask an athlete, they will actually tell you they become much better at sweating if you control your temperature. And so part of being prepared for a big race or a big sporting event is to train your sweating system. So don't abandon all your clothes. Encourage your body to run a higher temperature and become efficient at sweating, because by tooling up your sweating system, you'll become much more thermally tolerant. Similarly, if you're in colder environments, you get used to and your body adapts to constricting your blood vessels, keeping blood away from your skin, conserving heat in your core, etc., etc. So we can adapt, but there are limits. And certain individuals probably are better at adapting than others, and some individuals have a natural inbuilt insulation that makes them more resilient. And on average, women have more subcutaneous fat than men do, so women are better able to cope with sudden exposure to cold. But interestingly, women also tend to favour higher office temperatures and home temperatures than men do, which has led to perennial arguments over who has control of the thermostat. And many offices were designed when mainly men went to offices, and when women have entered the workplace roughly in equal proportions to men, we've now seen people saying, well, we need to have a rethink about how we run air conditionings and things, because women tend to say they find offices a bit too cold, and they haven't adapted in the short term to tolerate that, so we're having to turn the thermostat up a little bit.
Let's get a Zuki out in Bloberg. Welcome, Zuki. Go ahead for Dr. Chris Smith.
Good morning, Clarence, and good morning, Dr. Chris. Another temperature-related question. If Dr. Smith could please explain the relationship between blood flow and your nerves, because why is it that usually your extremities or parts of your body go numb when you're really cold? And also, is that the point at which your body parts go numb the same for everybody, or like how does it all work?
Hi, Zuki. Well, the reason that bits go numb is your first line of defense when you are too cold, apart from obvious things like putting a coat on, is that your body senses that it is losing heat rapidly through the skin. So the nervous system constricts blood vessels that supply your superficial tissues. And that's mainly the skin, but also your distal extremities. Because if you think about the surface area, your fingers and toes are a huge surface area to volume ratio. Lots of skin surface to act like radiators, and therefore they're a very efficient way to lose heat. In fact, the body uses your fingers and toes as thermal radiators to help you keep cold. There are nerves that go into your fingers that use various nerve transmitters to exact specific opening of blood vessels in your fingers to enhance blood flow to help you to cool down when you're hot. Now, the reverse kicks in when you're cold, clamps down blood vessels in your fingers and toes, and because they don't have a big volume, they don't have a lot of conserved heat in there, so once the blood flow is restricted to stop you losing any more heat, the temperature of the tissue goes down quite quickly, and when you drop the temperature, you are dropping the metabolic rate of the cells that are in those extremities. And if you drop metabolic rate, this includes in nerve cells, nerve messages aren't conveyed as efficiently or at all. And this is why if you go to sleep on your hand goes numb, because you're actually stopping the blood flow to the nerve, and this impedes the ability of the nerve to send nerve messages. The cold will do a very similar thing. It drops the metabolic rate. Nerve signals are metabolic energy, so if you drop the metabolism, you drop the ability to convey nerve signals, hence you get numb. And that's why your extremities go numb first. One, because you've restricted blood flow to stop them getting them throwing away heat, but as a byproduct of that, they get cold quite quick, and then the nervous system doesn't work as well in those extremities because you've got no blood flow and they're too cold, so you don't get any nerve signals coming in, hence numbness.
This one from Beverly. Why did the Lincoln reflecting pool in Washington turn into a green swamp? And what would be the most effective way to fix it? And that from Dr. Beverly Royce Miller.
Well, Beverly, I know Donald Trump made a big thing about putting some kind of fancy acrylic-based liner in the pool, which he paid a lot of money for, I gather, and then says that some people vandalised it. We don't know, though, why it went from this beautiful blue to a swamp again, because it had been a bit swampy, and Donald Trump wanted it cleaned up and looking blue. I know they put a huge amount of chlorine in, and that's a really good remedy, actually, for something like a swimming pool, because greenness is algae. Marine micro single-celled organisms which photosynthesize, capture sunlight, grab nutrients out of the water, CO2 out of the water and grow more algae. And as they're green, they just make the water go green. It's why the sea's green as well. And if you put fertilizer into the sea in the form of river runoff, you have these enormous blooms of algae in the ocean. It's probably a similar thing. It may well be they put loads of chlorine in there, killed the algae temporarily, but then the sun shone, broke down the chlorine, algae comes in from the environment, and there was probably some residual algae in there as well, which was a bit resistant to the chlorine. And in the warm water conditions, and there being lots of nutrients in the water, it then came back with a flourish. Other people have speculated perhaps some vandals, as well as damaging the nice acrylic floor, perhaps they dumped a load of fertiliser in there, which would have made an algal bloom and made it go green. But we don't know, is the bottom line.
And Andre wants to know, is there a scientific explanation for xenophobia? I know it's a psychological disposition, but we are in the throes of such conversation in South Africa as well. Is there a scientific explanation for xenophobia?
Well, if you think about not humans, but other animals that operate socially, dogs, for example, form packs, and they know who their friends are. Wolves form packs. They know who their friends are. They know who their adversaries are. They know who rival packs are. Primates, like chimpanzees, know who their particular clan is and who's an insider and who's an outsider. They know who rivals, therefore, are. So evolution-based principles, like Darwinian principles, favour an aggression approach rather than a passive, let's all get on approach, because it's survival of the fittest, survival of the strongest. Social species, survival comes in numbers and knowing who your friends are. And therefore, we almost have an evolved tendency, because of the way we've been successful and we've been selected to have these traits across the animal kingdom over millions of years. We've been evolved to have a strong kind of inward-looking, we're this group, we look after each other mentality, which, when you flip that round, means, well, you tend to be suspicious of individuals who are not part of that group because they might be trying to attack you. And so there is, some argue, an inherent tendency towards being suspicious of people outside your group. And that's why we have these behaviours.
And it's a base instinct by the sound of things. The following question for Dr. Chris. Can our body live without sodium?
No, absolutely not. We have enormous amounts of it in our body. Most of it's not in our cells. Most of it's in the fluid around our cells. You have sodium and potassium are two of the really important so-called cations in your body. And sodium, because it binds water, is responsible for us having the concentration of fluids that we do and hanging on to water in our body the way that we do. It's really, really important as a salt that we have, but we don't want too much of it. We don't want too little of it. If you didn't have any of it, then you would certainly not function, because your nervous system and all of this, every single living cell in your body relies on a certain concentration of sodium outside the cell and a certain concentration of potassium inside the cell to have a voltage across the cell membrane. And that voltage does a really important job helping to pump materials into cells, pump things out of cells, send messages down nerves, and make muscle cells contract. And if you don't have that gradient, that difference between the concentration of sodium and potassium, none of our tissues would be viable. So we absolutely rely on that. So, I wouldn't want to be without sodium.
And I think a question a lot of people are asking themselves without knowing. From Tebo, morning, Clarence, what causes early morning throat phlegm discharge, even when one doesn't have a cold or flu?
Well, the reason is that we produce from all of our mucous membranes, and the clue's in the name, secretions. And those secretions are a mucus, which is a material which has got water in it, proteins like mucin antibodies, especially IgA antibodies, which we use to defend our mucosal surfaces, and then other things like lactoferrins and various chemicals that break down or inhibit microorganisms. We secrete these chemicals all the time over all of our mucous membranes to help to defend those surfaces, keep microorganisms at bay, and in the case of your mouth and throat, to help you to swallow, because if you've got a slippery surface, things slide down easily. When we go to sleep, we don't want to drown in our own body fluids, so we turn down the secretion of all of these things. You make less mucus in your nose, less snot, you make fewer tears when you go to sleep, and you make less saliva when you go to sleep, because you don't want to be drowning when you're asleep. The consequence of that is that you do end up with a drier throat, you do end up with drier eyes. That's why you get sleepy bits in the corner of your eyes, and dry eyes that are a bit crusty when you wake up, because the amount of secretions has dropped, and hence you might find that phlegmy material has become a bit stickier overnight because the amount of water in it has dropped, because you've produced less of it and more evaporation has happened at the same rate, and as a result it's become thicker and you have to clear it up when you first get up in the morning.
We're gonna squeeze in Luke's question. He's from Gauteng, and he reports that, and I'm quoting, we are experiencing weird weather patterns in Gauteng, in Johannesburg. He wants to know why it always rains and why they always get extreme weather over weekends. The good weather is during the week, but the strange weather happens over weekends, and he's upset about it. What's your advice, Dr. Smith?
Well, actually, people have looked at this. Is there a weekend effect of the weather? And the answer is, to some extent, yes, there is. Because when you think about what we do during the week, most heavy industry, traffic, dirt and dust and pollution producing activity from commercial and other endeavours, that's happening during the week. This is putting into the atmosphere lots of aerosols, chemicals, dust particles, dirt and other things. These therefore rise in concentration across the week, and some of them do have the effect of being nucleating. In other words, they attract moisture to form around them as droplets. So you're adding some energy, but you're also adding a lot of nucleating sites into the air during the week because of our activity during the week, which is going to peak towards the end of the week. This could have a climate forcing and therefore rain forcing effect, increasing the likelihood of cloud formation and rain at the weekend. It all rains out during the weekend. Our activity levels are lower at the weekend. This resets the system, and it's lovely, sunny, clear weather for Monday back to work. Isn't that lovely?
So there we go, Chris, or rather Luke, thank you for your question. And I do believe you going on a bit of a summer holiday. We're going to be missing you. And for how long will we be missing you?
Well, I'm going to have a couple of weeks off, but that's all the more time for me to do some research onto cube-shaped wombat poo, and also for everyone at home to come up with all kinds of exciting questions for my return.
Enjoy your well-deserved break, and we're looking forward to having you back on then after that break. It is 2 minutes to 10 o'clock. Orly Kalinga now standing by with Eyewitness News at the top of the hour.